Everything is disorganized. You can go over there and you can all just fall over the edge there. And you can go in the rubbish. Wow, YouTube is really messing with me lately. Oh well. Keep it up. Hey, Lord Twister. Yes, indeed you don't, because I really don't have a strong recollection of you. So, welcome, Lord Twister, to the infrequent stream. To be fair, I'm not doing streams very much lately, and I've just lost my length of solder. Found it. Hey, Miles and Christos. Okay, just... Alright. Let's start disassembling this thing now. So it's liquid damage through the keyboard. There's really no point putting any power to it. You're only just going to create more damage. So best thing to do with your liquid damage jobs is get the board out, have a look at it, clean up anything that looks nasty before you do your first power up. Hey there, Yate Computing. Hey, Christian. Oh, well, Lord Twister. At least you managed to catch this one, so you can sit back and enjoy the ride or lack thereof. Victor Young. Okay. Oh yeah, battery, trackpad. They've already peeled that off. There's no screws in here. Oh, hilarious. But they left the battery connected. If you are going to ship a computer to me that has been liquid damaged, please just leave the battery disconnected, because if there is any energy in that battery, the whole time that is in shipping, it is going to continue to do its worst to the poor computer. Hey, Grand Prime. Messire is here, and PR, Maddie. Okay. Let's see, we need a T4 here. Now this is a 1521 board, so they're not the most difficult board to work on, but they can have a few quirks that make them quick to die with no recovery. So hopefully that is not the scenario here. I guess we'll see. Maybe there's actually nothing wrong with the board. That can often happen, and it ends up just being a chassis job. Hey, Wantamec. Alright. Okay, this has... Oh, shit on a stick. Alright, so this... Okay, it was scrubbed with isopropyl, and yep, okay. So now we've actually got to try and work out what was wrong, and yeah, our job is quite a bit harder now. I'm going to gather, and they connect the battery on after this, that was great. I'm going to gather here, this looks like carbonizing. Yeah, so there, whatever happened here, it got quite unpleasant at this point. Now they've knocked off a couple of caps, probably to get rid of the short, but yeah. Alright, Miles, come on, the 1466s are easy to disassemble. Okay, that'll be ground. Okay, so no short on there. Nick Vasey, John Lockhart. Thunderbolt could be damaged. Okay, the debug section here, there may be some issues there with those pull-ups. we'll have a look. We've also got some there. Let's see if any of these move when I touch them. Yeah, it's probably going to be cactus, this one. Because, see, we've got damage here on these two chips. And they supply power to, I think, pretty sure that's a switch mode that either goes to T2 or the RAMs. I'll bring up the board view and schematic and have a look, but it's probably, that one's gone to, okay, I don't know if that's a resistor. Yeah, okay. It kind of moved. And we've got eating out here. God damn, this is definitely a data job, if anything. The PCB was a little bit squishy, yes. Can't tell if liquid got onto that ISL or not. It could just be contaminated from touching. There's a little bit of liquid did get around here, which is bad. That gives us some of our CPU rails, I'm pretty sure. Okay, and we've had liquid all through here on the CD3215s. Ugh, this is going to be a freaking nightmare. Yep, this is no easy job, this one. Okay, that looks like it's borderline. What you'll find, if we have a look at the rail, there's probably a common rail that has eaten away everywhere. Yeah, the speaker is definitely, won't be surprised if that's shorted. Alright, in this case it's not. That's me just cheating there. And I think that is 1V8 S2, I think. Alright, time to bring out the board view and schematic because my mind is not as sharp as it needs to be. Yep, 1V8. Okay. Alright, that's probably why it's not going to give any attempt to come up. So we've got to find out where that particular short is. So we should have a diode reading of 0.385, but if we're beeping like that, it's going to be below 0.1. Let's see. Yeah, it's pretty much a dead short. Trouble is, it's not going to be a simple case of, oh, well, there's a short, you know, let's just remove it. There's going to be a considerable degree of secondary damage going on here. Okay, yeah, let's see, Q7680, what are you for? Okay, alright, these two here, that's for 5 volt and 3V3, they're our primary start rails. A moose, yeah, the problem is now though that due to the way they do the security model with the machines, there's basically you need the T2 involved in the process, and as a consequence, I guess Apple decided, you know what, this just isn't going to work. Whereas before, the machines with the lifeboat, they didn't have the T2 on them. Hey, Ed Boss, how's it going there? Now, I always forget where I have it. Oh, it comes out of the PMIC, I'm pretty sure. Yep. 1V8 comes out of the PMIC. Alright, so... And it looks like we've got liquid damage hanging around under there. And it looks like the very edges around it have lifted up a bit. But that could just simply be from the wash. That, yeah, maybe they were a little bit aggressive with it. Okay, so I'm going to go through and see if anything comes up as shorted around the PMIC, which it should. Yeah, always that one. And if we look at the schematic, yep, there we go. So what we'll do is we'll take that inductor away and we'll see if the short is on the PMIC side or on the system side. Okay, Keith McDermott. Hopefully we don't melt anything in the process or make anything explode. If it's the PMIC that's shorted, then you know, it's not going to be fun. The main reason being is that the PMIC, it's not the worst chip in the world. It's kind of like a little iPhone CPU, but it's an expensive chip to replace, and most of the time if it's been damaged, then it's usually taken out something else along the way. Okay, so here we go. Okay, so the PMIC's not shorted. That is actually a nice little moment of hope, which probably won't last long. The other problem is that the short is 6.9 ohms, which is, yeah, it's a concern. Because that tends to now implicate the T2. And that's some pretty frickin' ugly stuff up there. Yeah, so I really am being quite foolish continuing with this, but I'm still doing it. I guess you sort of want to get to the point where you can provably say this is what is wrong. So we'll yeah, and the other problem is 7 ohms onto a rail that you can only put at the most 1.8 volts on. You're not going to get a lot of activity in the thermal camera. You'll get some, but you're not going to get a lot. And I can almost bet my boots, when I put power onto this rail, it's not going to behave as if it was only a 6 or 7 ohm. It's going to behave like it's 100 ohms or 1k. It's just a weird quirk. Oh, that current and voltage reading that you can see jumping around, that is actually the USB-C input, which actually does not need to be active anymore, so we'll disconnect that. There we go. Nice and quiet now. The USB-C was actually charging something else. But these 4 caps here are all on the same rail, so I can afford to bridge them. It's a pretty ugly connection there. Sufficiently secure. Morning, Greg. Okay. They weren't stamps. See what it gives if I put this out. Yeah. Let's go up to... Okay. 300 odd milliwatts, so we might just get to see something. This camera will pick up anything down to around about 250 milliwatts of output, but it depends entirely on where it's being generated. If it's inside the CPU or the circuit board, you generally won't, because it becomes too diffused by the time you get to see it. Okay. Come on. There we go. Let's see if anything shows up. I have a strong feeling that is going to warm up. Ooh. Not the case. Okay, I'm happy for that. Hey, Tony W and 3X. Let's see what on this side comes up. Okay, it's over here, which is our CD3215s. Interestingly, both of them are down. Although mostly just one. Alright. That's a good starting point. Probably is a red herring, though. There is liquid under. It's saying that one there. Which, honestly... It gets tricky to tell. Oh well, doesn't matter. If it's a red herring, I'll just reball it and put it back down. No underfill on these ones, thankfully. Not that I have a huge problem with underfilled 3215 chips. They're not the worst to flick off. Yeah, they got fairly large and strong pads on them, so you can usually just get a fine metal spudger under them. This here is what I'm more concerned about, but we'll see. We'll see how the rail looks now. Yeah, see, I mean, that's still massively, massively no good. We'll take the other 3215 off because it was also showing some signs of heat. Like I said, it's not a major issue to clean them up and put them back down. And unfortunately, now that the resistance is approaching 20, 30, we're not going to be able to really pick it up. Hey Darren. It looks like that's starting to get up there. It's still not ideal, but 382, it's actually a pretty good improvement on the other one. Let's see what diode mode seems to think it is. Okay, we are actually up to what our diode mode says it should be. But there's just so much damage down here. Hey, Paul Marrow. I was glad to see the T2 at least didn't light up, because that's a fairly common way in which these boards fail. You know, something upsets one of the PMIC rails and subsequently the T2 goes, I'm out of here. Hey DJ, good to see you. Any board repairers in Melbourne that want to have a look at your coffee machine board? Which coffee machine? I'm just going to put a little bit of leaded solder down here. Need to put that inductor back down. Runcillo machine. Okay, I don't know that brand. My brand knowledge is probably limited to things like Segafredo, Vittoria. That's about it. In terms of Italian style. Alright, so it looks like I learned of another Italian one. So this is going to be a problem too. Like when we connect, that's the trackpad keyboard. When we try to connect, that's not going to play ball. That there is concern. Yeah. These here, see what those two caps were. I'm pretty sure they're just speaker or 3v3 or something like that. PV bus, G3 hot. My bad. Not really. What are you? 10 microfarad. What about 16? 10 microfarad. I'll put one of them back on. Hey, Blazing Magazine. First thing I have to do though here is take off the old pads of the cap. That copper tone that you can see on the pads there, that is the inside of a capacitor's end caps. So it's the portion of the capacitor that attaches to the ceramic side. So you've got to get that off. There we go. Bit of muck and junk down there. All of this stuff around here is ground, so it's no big issue. That was touching to that. So what was it? 10 microfarad, 25 volt, 603. Isn't that my classic 1466 cap? I did order a reel of a few hundred of them, but it hasn't arrived yet. I'm pretty sure it's these ones. Yep, 10 microfarad, 25 volt. Okay. Do you have a go? Aha, no. Unfortunately, I am definitely at the point now where I have to, unless it is, I just don't have any time at the moment. I wish I did for these sort of more interesting projects like that sort of copy machine, Paul. But the reality is that I've let down a lot of people in the last couple of months with not being able to attend to the things they've sent me. And I certainly don't enjoy disappointing people, but it's just the reality of it that I simply cannot find the time and energy to get to those other things. Hey, Oliver. Ah, sweet. Crikey, heck and heck. That is actually hotter than I thought. Let's put that there. So I don't want to melt the connector, so I was holding the metal shield with my fingertips, and well, my metal being what it is, conducted that heat quite nicely. Ach nee man, baie krach. Yeah, Paul, the spirit is willing. Like, I would love to do stuff like that, but I just know unless it ends up being a... Frickin' heck, that's frickin' hot. Unless I opened it up and straight away went, oh yeah, I can see what's wrong, it would... Look at this, see, this... lucky it's just a cap. But, hey Michael Tritz. Yeah, Miles, when the pressure's on, the Afrikaans returns. See, when you don't have a microscope and you're just aggressively brushing down a board, this is the sort of thing that happens. You start knocking parts and you don't even realise you've knocked the parts. So I don't know what rail that is, but it definitely knocked it off. It looks like it's probably a 3 or 12 picofarad probably. And it's a 12 picofarad, 100 volts. Crikey. Yeah, we're just going to have to live without that. So I appreciate the person having a shot at it, but I think in these sort of scenarios it just really needs to be left alone and sent forward. But like I said, I'm sure, well, I know I'm guilty myself of doing similar things. That's different, it was me. I got to choose. Hey James. Alright, so the real problem we're facing now is there additional damage that absolutely needs to be resolved prior to powering up? After I put the CD3215s on. So this here looks fairly nasty. Just digging around, let's see, what are you? Alright, so this is actually all PP bus stuff. PP bus. So yeah. That cap. At least if a PP bus cap shorts out, it's not the end of the world. You know, it's sort of a case of, oh well, you knock out PP bus, no biggie. Yes, that was a conical tip. That is the 0.2mm conical tip that comes, it's the smallest one you can get on the Hacko micro pencil. See, now this one definitely concerns me because that is going to the CPU. That's PV+HS CPU. Which gives us, let's see, VCC IO SO CPU. So I am somewhat inclined to replace that. That connector is botched anyway, so if I melt it, it's no biggie. Trying to decide, I'll leave the, this is plastic, so this is the edge of the CPU. It is going to be a bit of a tricky removal. So I don't mind the connector getting melted, I just don't want to upset the CPU too much. With the USB-C meter that I'm doing, now that I've got it reliably working in Linux and it'll actually auto scan the I2C bus and find everything, you don't have to set any specifications, whatever. I am going to try it on Windows and see if I can write a Windows program that will do the same as what you can see on screen, even though right now it's showing nothing. And I'll also do the same for the MacOS. Okay, struggling to get the heat I need into this. There it goes. We're also going to take the cap and the resistor. Hey creature, how's things going on your side of the planet? So in the end, the USB current meter thing, it will basically just have the INA 219, and then I'll have a AVR handling the communications between the PC. I could just use something like an FT232 or something like that, which they often have. I'm pretty sure one of them's got an I2C system on it, but it's very easy for me to implement it on the Tiny 45 or Tiny 85, and it's cheap as. And it gives me the opportunity to be able to flash something else onto it if I wanted, some sort of different behavior. I might take the opportunity now to remove this connector because we don't actually know what damage or corrosion's going on underneath. So your gold trip was a success, got food poisoning and stuff. Oh wow, with 3.5 grams of gold. Well, that should cover the medical bills, right? Should consider an ESP3286. DeAndre, yeah, wireless is basically not something I'm going to chase because you already can get wireless USB-C meters, and I hate them with a passion. Mostly because they all use the Bluetooth stack, and Bluetooth just sucks. No offense, but it's terrible for doing rudimentary communication, serial communications and things like that. Whereas this, it just plugs into, USB port on your PC. That gives it the power. That's the other thing is, due to the nature of the USB-C connections, unless you have it connected to a device currently drawing power, it will not be operating. So you have to wait, like say with something like an ESP with Bluetooth, you're going to have to wait for a bit after it has powered up to boot and connect, all that sort of stuff. So it's a pain. The other way around, of course, you could always have a battery on it, but then that's more complications. And like I said, that market's already covered. There's already Bluetooth enabled USB-C meters. In fact, I've actually got one. I think Jim Hook sent me one, and it was such a nightmare that actually, my apologies Jim for listening, but that actually went in the bin. Because I was trying to sort it out and it just wouldn't sort out, and I got mad with it and I threw it away. Jim's gonna hate me now. Now, ideally, I would prefer to just to connect up to normal serial, like RS-232, but the I2C, if I can get it reliably working on Windows and it auto scans and finds it, then I'm willing to go for it. On the upside, at least you don't have to try and... Yeah, it is a bit easier, hopefully, than dealing with COM ports. And the speed is good. I've got no trouble with speed. I can easily do 10 or 100 samples per second. Alright, so that connector's done. We've got to get ourselves a new MOSFET and supporting chips there. Someone popped by Nihil's chat. Edge. Oh wow, it's been a while. I haven't seen Foxabillo for a while. Let's see, okay, I need another one of those MOSFETs. So what do you... Something weird, find a part. Who, Edge has the off-grid homestead or Nihil? Because I know Nihil was doing that for a bit, but I don't know. Yeah, it looks like a lot of devices have this MOSFET, thank God. 239 has it, so that's a good start. Oh, Ed, okay. Alright then. 840, 850. Alright, this is good. This is a fairly common part, thank goodness for that. Nothing worse than being stuck with needing a part. Even more reclusive. Yeah, at least I'm actually on the grid. I have electricity and all that sort of stuff. Okay, stop. Q7900. Where are you? Looks like that one there. I'm not so much recluse as in I just don't like people visiting me. The reason I don't like people visiting me is because I can't escape them, and it's usually off not the sort of schedule I want to keep. If I'm going to meet people, I'll meet them down at a neutral location, downtown or something, and with a situation where I am not the only person there, so to speak. So if I happen to decide, you know what, I'm out of here, I can just up and leave and they're not left all alone. Oh, good on you. Yep, great. Everything else is moving before that. How many cats? The answer to that is yes. Miles, at least with the M1 series now, the M2 series, they do put the important MOSFETs and things like that inside the cage now, so that's excellent. That's interesting. The resistor that's up here is actually, it's a 1 ohm resistor. 1 ohm 201. Fairly sure I got a 1 ohm 201. One meg, right, that's a bit on the opposite end of the spectrum there. 1 ohm 201. Yeah, boss, it's not, like I said, I mean, yeah, in some ways I feel bad because, yeah, I've got people that come out all this way, yeah, and they're coming to say hello to me, and I appreciate that aspect of it, but unfortunately, it does sort of give me the it just, and it actually makes it difficult to have a good conversation with the person. Okay, so the capacitor I need is a 2.2 25 402. 2.2 25 402. 402 caps. Now Lewis would be saying if you had a donor board you wouldn't have to go through all this drama. And that's very true. But I often find with many of these I prefer to use the new parts where I can. Just to absolutely, oh shit, I'm out of. God damn it. Okay, see if there's any left in here. Yeah, because when you start peeling that layer back off the tape, sometimes a few of the caps fall out. This is another one that I ordered a whole bunch of and I'm still waiting on. Crap. Doesn't look like there's any in there. Could have sworn there was 1 or 2 left. We're looking down the bag in case you're wondering what the hell we're looking at. Well, looks like this one's going to have to be a donor source. That's annoying. I think I ordered about 1,000 of those. Because they keep coming up as being a cap that I need. So what do we want? 2.2. Oh, good. Okay. Finally use some of my 1534 boards. Terrible, terrible things. Nasty, nasty little pieces of work. Let's see. 45 board. Somewhere in here. That one there. That's it. What I hate, Miles, though, is that I still only get around about a 1 in 3 success rate with those 1534s. And more of them now seem to be faults that I just can't, their actual SSD section of the CPU that's crapped its pants. Whereas at least when it's just the general CPU itself that's got problems, you know, you can do the reheat temporary fix and get the data off. But with these CPU with the SSD section failure ones, you just can't do it. It'll taunt you, because you know you get an Apple logo and whatnot coming up, and you go yay, and then it says nah, change my mind, you're not getting the data, and shuts down on you. Brings up that nice little flashy folder. Hey Chaz. So I'm going to be a little bit crazy here and try and double reflow these parts. Come on, man. Oop. Ow, hot. Yeah, that's not very good job there. That's okay. Oh, I gotta work out where pin 1 is. I'm gonna guess this is pin 1 over here. No, I think... No, yes, no, no. Yeah, I'm wrong. I was thinking it might be pin 1 because I could have sworn that was the gate drive, but it seems like it is not. And this, in fact, is the correct orientation. My bad. Pin 5 being a gate, is it? Yep, pin 5 is the gate. Travis, looking for a smack in the head again, I see. Looks like nothing much changes with you. What I'm going to start doing is actually sending, you know, if the machine fails from something like PCH failure or whatever, I'm actually going to give people Travis's details and say, here's the one that caused it to fail, and so you can take him to court or whatever and get your justice. Yeah, 1 and 2 are merged together. Alright, that chip is actually skewed off to the left a little bit, so I'm going to have to reheat that. I can just see that the pads, they've got a bit of a pull effect on them. which means the center pad probably didn't get hot enough. See, ideally, if you've got the right amount of solder and the center pad's hot enough, it should just yank itself back into location. It's still not going. I can... Damn you. I'm just cooking shit here now. And it ain't meth. Yeah, I'm just gonna have to leave that. Fortunately there is enough clearance, but it's not great. We've still got to put the CD3215s on. Now that in itself is a bit of a problem too, because I actually don't have any left. So I'm going to have to pull some from somewhere and reball them. I have got plenty on order, but, well, lately shipments from various suppliers are pretty much useless. I'm just touching up the end caps on these parts, and if they come free, then at least I know that yes, it's my way of detecting if there is sort of cavities underneath. Because if there's no cavities, then they usually won't come free. But that was different, because that was me applying too much heat overall. So we'll just have to put 2 new resistors down. Yeah, I didn't let it cool off enough before I dabbed it again. And subsequently there was enough heat overall to lift up both those parts. Now I'm going to go and find out what they are. Let's see. $10K. $10K. Pair of 10Ks. Okay, creature. Have fun walking the dog. So we go again through the pile, 95K through, here we go, 10K. The more commonly used parts tend to float to the top of the box. It's the most recently used algorithm. There is such a thing. When you're doing paging with operating systems and you need to page out memory to disk and things like that, you can have least recently used algorithm or the opposite, oldest page swap out algorithm. There's a lot of other more complicated algorithms. I doubt they use such simple algorithms anymore. Least recently used and most recently used. LRU, MRU. Anyway, my components use the MRU algorithm. Hey ZX. We've got all this drama here too, so we'll replace that one and that one. And, May as well take this off. Pretty sure these are overcurrent protection assemblies. Yeah, the resistor looked like it might have been okay. To be fair, the resistors are probably okay, but it's more actually the problem of trying to find those cavities. You got to diagnose these boards like you're a TWA employee, and you got to find those cavities. Yeah, the pies do like to die a lot. Fortunately, I do have stock of those too. Okay, top one is 10K. Bottom one's 10K. Do you ever get the moments where, for whatever reason, you just all of a sudden can't seem to see through your microscope for a bit? It's like your brain just can't lock you in on the correct positioning. Top right pad of what? Pin one down there. Oh, that. Fortunately, that just looks like it's just a little bit of, what do you call it? Conformal coat. It's just ablated off. It's not actually corroded. Thankfully. Need to use this to get down on these little pads. Getting in all Jason Vilma style here. That crazy Floridian. It'd be crazy if Lewis moves to Florida. Ah. That's got to be a ground pin. All I need is Jason to turn up. He's got a spooky tendency of turning up just as I'm kind of abusing him. No flux. Well, that's good wick, but because I had used it before, I think all the flux got driven out of it. Yeah, that's what happens when you put flux on it. No, Jason can be a lurker, but he likes to also say hello. He could also just be on holiday or something. Cycle of abuse? Are you referring to the fact that Lewis tries to abuse me? Pi 32 USB. Hey, Joe's Tech. Yeah, waterproof phones. Yeah, that's a joke. I did see that video. I haven't actually had it, as in I saw it come up on YouTube. I haven't had a chance to watch it. It's kind of sad. Lately, I'll sooner catch Lewis being an idiot than anything useful. And it's kind of getting annoying. I don't mean annoying as in it's annoying that Lewis is being an idiot, no. I just mean when I'm trying to go and watch a video, it'll be those ones that I will inevitably catch rather than the ones that I really do want to watch. I've got no problem with people doing idiot videos. In fact, I think it's quite healthy to do that. Also stops your audience from getting too stuck up themselves. Flushes out the ones that can't handle reality. Okay, I just have to clear up all the pads. Hey, Joho. Yeah, Arnold G. I think Jessa Jones did a bit of a tongue-in-cheek video with regards to that sort of thing, and it was pretty sad the amount of backlash that she copped over it. And I was like, geez. It was clear it was a joke. It was even listed in the title it was a joke, and yet people still just couldn't hack it. And I was like, alright, maybe the internet's not the place for you. It was an April Fool's video too. Yeah, Paul S, he does good videos. He's very, is a good person to do videos. He's very pedantic about his stuff. He knows what he's doing. He's quite brilliant, which is why we all harass him. If you can't work something out, you try to get Paul S to tell you how to fix it. I don't really have that privilege, but I would if I could. Alright, so we need two 3215s. This is going to be fun. Yeah, I'll take my chances with these two. Do you prefer the conical or the knife tip? It's a situational call. Yeah. Conicals are, for the most part, nearly useless, but they actually are useful at these scales. Like when you're trying to put some solder down on a small point on a 201 or 105 type part or pad, that's when the conical tip actually does become invaluable. Beyond that, yeah, I'm more of a knife tip or a chisel tip. Oh boy. Fortunately, I don't really need to bring these down to, what do you call it? I don't need to bring them down to perfectly flat because we're going to use solder paste. See, people, I do use solder paste and balls. God damn it, I'm going to have to use the bigger chisel tip. The main purpose of this is just simply to get leaded solder down on them. No good. Damn it. Okay, you remember I talk on the SMCs about how if you see delamination occurring in your chip, just get rid of it. So this one here, it is starting to delaminate just in this area here. So, oh, and over here too I can see it. So yeah, that's a bin job. I do also use the JSO2, though not very much anymore. I think the JSO2 definitely had its place at a time when you didn't have any other choices or you didn't have the equipment on hand for... And so like, yeah, okay, well we've got one soldering iron, you know, what's the best we can do? That's more universal, and the JSO2 is very nice for that. Okay, that one looks good. There's no delamination that I can see in that one. I think ideally, if you just have multiple tips, it's great. Yeah, you can pick and choose as you need. That's why I'm very glad to have two stations now. So I've got one set up with the... oh, god damn it. I've got one set up with the chisel tip, you know, for the heavy lifting, and then I've got the micro pencil. That's going to be good enough. Now we've got the process of getting the stencils, doing all that stenciling trash. Let's see. I've got one of those nice stencils for the 3217s. That's a very nice stencil to use. It's compact, it doesn't warp out of control or anything like that. Because see, the problem is a lot of the stencils where they're the compound ones to cover many chips on a board, all that extra metal, you have to bring that extra metal up to temperature as well, so you don't get buckling and warping. But if you have a small stencil, just a dedicated one chip type stencil or very limited number of stencils, it's very easy to stop it from buckling because, yeah, it's only just a small amount of metal to bring up to temperature evenly. Yeah, so like this stencil here, it's going to require a little bit of TLC, a bit of gently getting it there, sort of foreplay it sort of thing. No rushing in. I'm just dishing out some solder paste at the moment. Just remove some of the flux from it. This is perfectly good paste for if you're doing a new board, as in you're prototyping or something like that, and you've got some fine pitch parts and stuff like that. You want all the extra flux, but for these scenarios, we don't. We kind of want it more of a thickish paste. God damn it. Probably could have dried that a little more, but I didn't. C'est la vie. Hey, micro repairs. Hello there, Mr. Suckin. Alright, so I'm going to go at this with 250 centigrade. And 35 air should be enough. Just going to get slightly chunkier tweezers with this task. I'm hoping I can get this to transition before the stencil transitions. And by transition, I mean it'll go boing and pop. Come on, you can do it. I gotta admit, I am actually trying to warm up the stencil concurrently. I'm fairly sure not all of those balls are actually attached to the pads. It may look it, but I'm gonna go at it with the hot air again. I think a few of them might be just simply sitting there without actually being bonded. Sarah, this is actually it's just like a Mac 5. It's from Fixing Things For You, sent them to me. There's probably a little bit too much flux there. So we'll just have to be a bit careful. see if we can do this with a very... I'm going to try 360 and 40% air. So it's not a lot of heat and it's not a lot of air. Because it is leaded solder, so I'm just waiting for that flux speed to... Okay, flux speed's down. Now this is either where it's going to fly off. Fuck. Yep, as I was saying, too much flux. I knew it when I did it. Fortunately, it didn't actually connect. Often what will happen when that sort of thing happens, it will... the balls will have melted just enough that they sort of do a bit of a cold weld, as it were. It feels like a cold weld, but it's not. But needless to say, it's enough to ruin your day, and you have to reball it. Yeah, that's why you shouldn't have too much flux. I had a feeling it was going to do that, because usually I only flux either the chip or the board. I might have to go up a bit more heat. These boards do absorb a tremendous amount. There it goes. And the other problem with at this low temperature is you have to stick with it quite a while, because what can happen is a portion of the chip does reflow and it pulls it into place, but there's a bunch of balls that actually aren't done. Ah, so many carpet fibers. Alright, that's one done. Now we're going to do the other. Which means I've got to find another CD3215. One that does not have delamination issues on it. At least they look genuine. A lot of the time also you can't see the delaminations until you sort of have run over with the soldering iron like that. Sometimes just the heat of the soldering iron will expose, it'll bring out and heat up any moisture or something that's trapped in there, and it has this tendency of revealing those delamination issues. It's kind of like puff pastry. That's probably actually the easiest way to describe it. Yes, they do purposely omit one so that you know which way you go. It's a pretty common thing to do. Or they'll shape one slightly differently. Yeah, there's all different ways they try to do it. Like you might find that one pad's square rather than being round like the rest of them. Things like that. Ah. Well, if you need 25 balls, then yeah, like I said, it all depends on the chip. How you go about uniquely marking it. Some of them don't have any indication other than just the marking on the top. Okay, so here we go again. 250 centigrade, 35 air. When I actually start doing something with my desktop CNC, I'll probably start creating jigs for these things so I can just put them on hot plates rather than using hot air. It's much easier if you just put it on a hot plate because the hot plate's nice, slow, steady. You don't get the dramas you get when you come to using hot air. Okay, we've got two non-believers. Okay, we've got one non-believer. Oh, come on, man. Don't be a holdout. Okay, the ball is still down there, so that's good. And what we'll do is just give it a itty bitty teeny weeny itty miny infinitesimally small amount of flux, which I failed on there. That's a hell of a lot of flux. And we'll just see if we can get it to sit down. Come on, you can do it. There you go. Okay, that's all good. Hey, Rilla. Ah, I see Kodak's here. Hello, Kodak. Just a few little undesirable carpet fibers. I desperately need to rip out all the carpet in this place. And then create a positively pressured room. It's the only way to keep the crap out. Let's see, carpet fibers. They're not cat hairs, they're not my hairs, they're carpet fibers. Very annoying. I didn't check to see if they actually were COOs. I'm a moron. That one up the top there, that's a BO3. Fuck's sake. I can't believe I did that. Yep, it's a BO3 up here. That's a BO3, not a COO. Good on you, folks. None of you has told me. You're all culpable. Well, we'll get the COO down. We'll have to take the BO3 off, throw it in the bin. That was a stupid mistake to make. It shouldn't be upside down for you because, yeah, if you're in the northern hemisphere, then... Oh wait, who said it though? No, if you're in the northern hemisphere, it should be the right way up for you. Too blue? Yeah, I'm not really caring about that, to be honest. I mean, you are right, but like I said, I don't care. One day maybe I'll invent a system that will automatically change the color balance for me on the fly. Ow, hot stuff. Okay, there we go. Alright, let's try that again. Talk about dragging it out needlessly. What about you? You're CO3. You're not even a... You're a lying chip. You had the look. Oh, this is a 45, not 244. Right. My bad. Me being silly. Okay, there's a COO for you. Probably would have been smart actually to grab both of these, but oh well. It's interesting to think back to the time when we first saw BGA chips, and it was like, how the hell are you supposed to even solder those? Like, I'm talking about the 1990s. And people would be losing their heads over even 1206 size surface mount components. Nobody's going to ever be able to solder these. My goodness, how things have changed. Kodak? Quite probably. Of course, it's not something I'm going to test. Oh, long since stepped away from that sort of self-abuse. Long. Over 22 years. When I got back from South Africa, it was like, right, change time. Nick, that is actually interesting. I did have had a few old tubes of stuff, and yeah, I never really... I mean, there was some small sort of changes, like it wasn't perhaps quite as homogenized as it was before, yeah, realistically, you're right. There doesn't seem to be a colossal amount of difference. It still works, doesn't it? Stuff still goes and gets soldered, and that's what matters. Ah. Sometimes you see little divots in the stencil, in the pads rather, and you know you're going to have to fill them in a little more. What I should do is just cut out this stencil. The trouble is, when you cut out stuff from sheet metal, there is a bit of a tendency, if you're not careful, for you to buckle it in a way that you can't really unbuckle it. Not too easily anyway. Interesting, this one's actually bobbling over a little more. I have done the glass reball method sometimes in the past, but I find if I use a lower temperature, I can get away without having to do that. So like I'm only using 250 centigrade here, whereas many times people will use 350, quite a bit higher. But I find when you go with the lower temperature, you don't tend to run into the issues that tend to require the use of glass. I know there's a bit of a dimple on this one here. Yeah, it's gone now. The amount of heat that a BGA can tolerate really is dependent on the BGA itself. Some chips are very durable, some you look at them wrong and they just die. A fine example of how things are different is if you try to take the Trident pack, I think it's the Trident pack, off an iPhone 7, you pretty much can never get that thing feels like it's a little bit off. Anyway, but yeah, the iPhone 7 has a triple coil pack on it. I'm pretty sure it's called the Trident pack or something. Anyway, it's an absolute colossal pain in the ass because the temperature you need to get it off the board tends to be greater than the temperature at which it will internally desolder itself or just suffer squeezage. You could probably do it if you took them from the underside, but then you still got to get back on the board. So in the end, if that coil pack is ever damaged, you just don't bother putting it back on. You put some temporary coils on there to let you get, I think it's touch or something, I forget which facilities you need it for, and you migrate the data to a new phone. That's the end of it. I mean, obviously some people are dedicated and they will do the full thing properly, but not for me. Okay, we're starting to move here. I don't think I've got enough flux. I've got the opposite problem this time. There are definitely some balls that have sat down on this, but I don't know if it's enough. Alright, it is dancing, so we'll accept that. Yeah, you can always add flux after the ball's met, exactly, yeah. Hey there, full wave. Diodes can be like that as well. Got trolled for 3 hours the other day because of that. Remove the diode from the donor and it'll be fine. Reinstalling too much heat and be back to... yeah. Yeah. I got trolled similarly like that a while ago. I'm trying to remember what... oh, it was the ISL 6295s. And I would measure the current sense input and it'd be like 95 ohms or something like that. We've got a problem down here. I can see there's a bit of cavitation on that chip. And then I would put the chip down, and as soon as I applied power to it, it would go back to being open circuit. Turns out that that actually is normal behavior. It just sort of, it gets charge in the gate, and consequently it just goes open circuit, but it is actually normal. But I was running around thinking, oh great, I'm destroying it every time, but I wasn't. So I think I must have replaced 6 or 7 of those ISLs on the board before I thought, you know what, this is just, I'm missing something. Okay, this chip actually does look alright, so I'm going to put that back down. I don't think it was actually cavitated. It's just sometimes with these parts where you have a consolidated pad, they can get that appearance. Yeah, see, if you push it down, it's all good. Hey Nick Vasey, you're out of here, are you? Yes, that's warm. This is the scary thing, is like I didn't see this corrosion before, and now I have. I suppose I should be happy, but it's also annoying. Yep, there you go. That's what I was worried about. I don't apply a lot of pressure, but you can see how that pad is just corroded out. And actually, now that I'm looking closer, I can see that that pad is missing too. Alright, more work. Never ends. I have a micro USB connector that seems broken. I need to apply sideways force for it to charge. Yeah, sounds like you're gonna have to replace the whole thing. Once they start going like that, that's usually the end of their road for them. That cat looks bad. You probably can't see that, but anyway, there's issues abound here. The worst thing is this is under the CPU area, so it does make it a little more demanding on the heat. Ah, for fuck's sake. What you heard then was one of the caps having a bad day. Very hard to avoid doing that. This one here, it just momentarily pops up. But this is going to be a data recovery job, so hopefully I can get away without having to replace that, because usually when you start replacing those, you inevitably knock out the ones next to it, and it becomes this process of removing all of them, and yeah, not much fun. Okay, so this could be a colossal pain in the ass. Yeah, the smell's pretty bad. Fortunately, the fume extractor is doing a good job in keeping that away from me. Yeah, it's definitely a mess. That's Gonski. Alright, we're gonna have to look at the board view and schematic. You can see there, that's also Gonski. That just breaks off. That one there's following, yep, there we go, that one's gone too. Ah, fun and games. Just gonna rotate the board to the orientation I want. Does vinegar clean corrosion on copper? Not sure. And me. Is this it? Nope. Ah, this is it. Okay, so this link here we've lost. Oh yeah, PP bus VO sense in. So what is this construction? Is it current sense? Okay, PP bus G3 hot, sensors for the voltage, and then right. Okay. All right. So yeah, that's a pretty much needed part. What's your role? You're a feedback from 6 to 4. Okay, so it goes that one, these two are merged, and then into there. Okay, so it's a divider with a feedback divider. Okie doke. Hey Jürgen. What I find curious about this is that we have a trace going off here, so that is actually picked up somewhere else. So that's just going down into a blind veer. This is going to be fun. Of course, by fun I mean annoying. Alright, so the one on the right is 100k, so it's good. Good because it's not some exotic value. And the one on the left is also 100k, so that's extra good. And there'll be 201s because they're itty bitty tiny weeny whiny things. So 201, 100k. You probably could get away with some other values, but we're going to find 100k. Let's see, you're 100 ohms or 100k? 100 ohms, right. The way I write my R's and K's is a little bit too close, so I can end up accidentally thinking I've got 100k, when in fact I've just picked up 100 ohms. Right, we've genuinely found 100k now. Arnold, I have no idea where that is. It would have been, it's, you know what, I have no idea where that is. I was going to say, maybe you can try this particular video or something, but no. No idea. There's one. I know the other one jumped over here somewhere. I kind of think it went down the hole. No, can't see anything. I know I definitely dropped two, but I don't know where the second one went. Ah, that's annoying. Definitely a good reason why ultrasonic cleaning is a handy thing, because if you do have any parts that have kind of scattered across the board inadvertently, then ultrasonic clean usually should displace them. On the other hand, it may actually just be a freakish situation and you ultrasonically weld the part to the board, in which case you've probably got worse things in your life happening. Alright, here we go again. Probably going to pop another cap. Or the same one again. I'm trying really hard not to do that, but... Alright, now we just need that chip, which is a dual... it's a NP combination. You just find it. Oh, it looks like that chip's everywhere. Thank goodness for that. Let's see if it's on a 165. Given the fact that it's on 10-year-old main boards, did I see 165 just show up then? I mean, 2915, come on. 164, 163. Way up there. Oh, of course. Q5500, yeah. That's just right above the 3V42 section. Wrong physical size, or is it? Oh no, it's one of these. Yep, okay, it's this one here. Yeah, I was thinking for a second it was that, but it's actually that one there. Oh, come on, I'm killing myself here. Uh-oh, I'm lost. Ah, right. Ah. Don't you hate it how when you try to not spend too much time heating up something, you inevitably spend more time heating it up? Okay, so we will need to run a wire from that resistor to that pad. I'm not trusting that there's a connect. There might be a little bit, but I'm not trusting it. Let's see, that is not even sitting correctly, so I might reflow that first. So at least it's in the appropriate position before I start the wire up. Oh, that's much better. When you're trying to stop the shakes and it gets worse, that's definitely a very annoying thing, yes. Impressively annoying. Just like me trying to find where I put my lids wire. Where'd I put that stuff? Aha. My favorite enameled wire. Favorite because it's thin, it doesn't fatigue too quickly, and the enamel comes off quite a bit easier than some of the other ones. It's got a lot of fuzzies on it though. DeAndre burnt out a regulator for the SSD. I don't know. Don't let Travis Stamper know about that. He'll start telling you that that SSD is cooked now. My wire is too long and I've got too much hair. Yeah, Greg, I saw that with the Elon Musk deal situation. I'm sure there's some reasons behind it. Maybe he just decided, he woke up and was like, you know what, I've had enough of Twitter, bored doing their crap. So dare say the Twitter board have been doing their best to think, how can we maximize how much we make out of this? Let's do it. Alright, so that's done. And right, we've got these couple of caps here. Got that one there and that one there. It's probably not absolutely essential, but they are badly damaged enough that it would be the right thing to remove them. Yeah, I think anytime Elon turns up looking to buy something, the first thing you do is try to increase the price by at least 10 times. It's the right business thing to do, I guess. And they'll be thinking, we're doing it for the shareholders. Someone trying to make a allude to the fact that he's talked about how many kids he's got. Personally, I don't really care what he does in that department. I do like SpaceX though. And I like the fact that Tesla's shook up the market good and proper. Whether they endure long term or not, I don't know. But I am happy to see that they pretty much kick the teeth in. Starlink's also pretty good. Hyperloop's probably a bunch of hyper crap. I don't know. It's not really my strength. That sort of thing. I think Virgin made a terrible attempt at it. I think, what Virgin do they? They created like a half mile or 1 mile track or something. And wasn't there a fair degree of fakery or something in the press release? I don't know, something about that it wasn't really what they said it was. I mean, I understand the concept of, the vacuumed travel tubes and all that. I mean, I remember a book I had from the 1970s or 80s talking about that sort of thing as the future of very rapid transport with limited, minimal energy input and that sort of thing. But I kind of wonder if that's where Elon got a lot of his ideas from. Probably the same book. Let's see. Okay, we need these 2 caps. Let's see. What are you? Jelly bean cap. 100 nanofarad, 10 volts is one of them. 100 nanofarad, 10 volts. Okay, so they're both 100 nanofarad, 10 volt. They're jelly bean caps, which is good. They're just there to give it a little bit of localized capacitance for the chip, which means you can get away with almost anything in place of that. I got 100 nanofarad, 16 volt. That's more than perfectly fine. So these are very much just general purpose chips. You'll probably find that most of the time they're not even required. They just help maintain stability. Yeah, I noticed Thunderfoot likes to, I don't know, he seems to have a little bit more than just a debunk thing with Elon. It's almost, there's a bit of animosity there as well. I don't know whether it's sour grapes situation or something else. You know, I've seen a few of Thunderfoot's other videos where he's debunked stuff and it's like, yeah, I get that. But with the Elon ones, it seems a little more hostile, a little more personal. I'm not quite sure why. Those caps are on. There's a little bit too much solder on that end, but we're not going to lose sleep over it. think we're almost at the point where I can plug in power and see what happens. Everyone's thinking, oh thank God, about time. It's been so frickin' boring. You've been going round and round. Nothing's been happening. I might just flux and boil that, see how it looks. You gotta be careful because sometimes caps, like just little ones that you think are jelly bean caps, actually might be extremely important, i.e. around MOSFETs and things like that. Sometimes these are gate boost drive caps, as in they are needed to boost up the voltage drive to the gate so that they can switch properly. So I'm just going to check, see what those ones are. TV7, okay, this is SSD stuff. So that's actually not CPU, that's SSD. So that's fine, that shouldn't be any boost requirement stuff there. Got that reconnected. Okay, that looks a bit ugly there. It is connected. That's a temperature sensor there, so hopefully they'll be okay. Like I said, this really is going to be a data recovery job in my opinion. This is not something I would hand back to a customer and go, there you go, continue to use it. All is well. It's a case of, thank you lucky stars, it was able to be recovered, back it up, throw it in the trash. Treat it like an A1534. I'm kind of worried that, I'm actually going to take that speaker amp off. These speaker amps, they're connected directly to PP bus, and they really do have a tendency of getting mucked up inside whenever there's liquid damage. Funnily enough, the same thing happens on a lot of iPhones, particularly the 6, I think it's the 6S, the speaker amp chip. It almost well, I shouldn't say always, it very often is a liquid damage victim and shorts out, which I'm kind of thankful for because many times it actually saves the rest of the board. Oh, I can't see. Sorry about that. Let me switch. Actually, I'm gonna put the board into the cooling system. It's awfully late at the moment. Oh, crikey, it's 1 o'clock in the morning, you bastards. It's completely unacceptable. Now remember, we do not have trackpad, keyboard or anything at all functioning on this one. I'm just picking up all the little pieces. I ordered myself 1,000 zippy bags that I normally use for putting these parts in, and the goddamn things haven't turned up, and it's been like over a week and a half now. I think I got scammed. Yeah, this is the size I use. It's about 5 by 7, so anything 5 centimeters or less in width is what I can use. When I say scammed, I don't mean they took off with my money or anything, but rather, instead of being in Australia, the stock, it's probably coming from China. And they'll say, oh, we're sorry, it was a one-off situation, we ran out of stock with yours, or the stock was damaged, or yeah, some bullshit excuse. Just so that eBay doesn't come along and remove their account. Not that it matters to them. These people run hundreds upon hundreds of eBay accounts out of the same warehouse, so you kill one, a dozen pop up in its place. And they intentionally, they'll use wording like ships from Australia or something like that, but it doesn't actually say stock in Australia. It's all just full of crap. You may as well just go to AliExpress and get a hell of a lot more for a lot cheaper. Okay, here we go. Fingers crossed. 5 volts. Not good. It's cycling. Same thing on that one. Alright. Okay, so it's doing something, but not great. Damn it. Typical. After all that work, still nothing. I'm just going to take the display connector off just in case, but I doubt it's got anything to do with it. It doesn't look like I had any contamination issues there. Alright, time to check some rails, I guess. That's annoying. I suppose I could see if anything's heating up. We'll probably find the T2's heating up and it's the end of the road for us. We'll have a look. Now, the downside is that this area is actually quite hot, so it's going to mess with the readings, so I'm going to put it just over here. Let's wait for this to come up. Come on, hurry up and boot. Okay. Yeah, the heat's coming through still. Oh, we'll see what we can do. Yeah, shit. Yeah. Straight away I can see over here. Okay, let's check around that PMIC. Greg, yes, that is correct, but it's predominantly because they're using a single chip rather than multiple chips to do that, provide the disk. Personally, I don't think it's as big an issue as what they're making out. I think they're just looking for something to kick and scream about. God damn it. Shit on the stick. Oh God, no, not that one. Alright. VDD CPU awake. Yep. That is T2 related, basically. Yeah. So was that? Is the cap in the lower right in place? What cap lower right? Everything is in place that I know of. Okay, so what we're going to do is we'll take that coil off and we'll see if our T2 is dead. And unfortunately, this will not be the first time by any means in which I have run into this issue. What I'm worried about in this, and this is a reason why I don't like it when places wash the boards with isopropylene or anything like that, is that you don't know what, goddamn caps popping all over the place, you don't know what has gone from the board and then washed under the chips. So it is entirely possible, that terrible smell, ugh. It's entirely possible that the T2 may have actually been fine, but then through the washing process, junk got under the T2 and now it's dead. I have a horrible feeling it's going to be T2. Yep, it's T2. That's a goner. Dead machine. I'm sorry. Look, I can... Yeah, it's dead. Honestly, I probably should have checked that right from the start, but I got too carried away. This is what happens when you chat on YouTube. Yeah, 1.7 ohms, that's way low. That should be around about 40 to 80. But 1.7, it's a little low. So what I'll do is, we'll drop some flux under there, but nothing's going to change. I'm not going to reflow it, I'm just letting the flux dance around a little under there. Now you can't replace the T2 chip because, well, you can replace the T2 chip, but you don't get to keep your data. That's the problem. By the way, this smelly cap, that's it there. You can see where it cracked. See? I hate these caps, the way they do that. They don't short out, they just emit terrible noxious gas. Kind of like me. Yeah, and see how it's going way down to 0.7 now that it's warm? That's a very dead T2 chip. Well, congratulations, we just wasted the whole night on a T2 chip. That's 2.5 hours that I'm not going to get paid for. Customers are not going to get their data. And sadly, it's pretty common for the 1932. So, my bad. I really should have gone through and checked every single one of those coils before I even went ahead with anything, but I got carried away, so my fault. It's the way it goes. Bugger. Hey Seth, why use flux instead of IPA for the T2? Because what I want with the flux is the flux to get under the chip and to gnaw away at any possible corrosion links or something like that by heating it, whereas the IPA won't necessarily do that. Yeah, sadly it won't be the last one either, no. Alright. Anyway, that's it. I'm out of here. Thanks for watching. Sorry it wasn't a winner. It happens. I'll catch you next time. See you later.